Okay, thanks for joining me for this session. So basically, we're going to talk about money, right? Unfortunately, I don't think you'll end up at the end of the talk really rich, but you will probably have learned if it's the case for cyber criminals or not. So there are actually different ways to abuse cryptocurrencies. And we're going to have a look a little bit how this is done on computers. Just besides smartphones, we'll put smartphones a little bit away. Abusing cryptocurrencies has already been done quite a lot on computers. Cryptojacking is one of those techniques. So cryptojacking is using your computer without your consent to do some mining and getting some money for the attacker. That's one of the things which is possible, one of the possibilities to abuse cryptocurrencies. An example of those is the malware which is known as Zero Access botnet, also known as ZeroFF. And this one is abusing and mining cryptocurrencies behind your back. The way to be abusing those is wallet stealers. So this time you're going to grab the money exactly already where it is inside the wallet. So you'll get the private keys of the victim and basically empty his account that way. There are plenty of different ways to implement wallet stealers. We'll see that a little bit afterwards, like fake wallets, that's one possibility, but also clippers, which are manipulating the clipboard manager. We have also ransomware. So ransomware, what is the link, the tie with cryptocurrency? It's that most of the time they are asking for the ransom in Bitcoins or some other cryptocurrency. We'll see a few examples for that. One famous, perhaps, that you have seen, or that I like a little bit, is this one, the Kirk ransomware on Windows, which is actually paying a tribute to Star Trek. And so it encrypts all your files on the computer, pens an extension .Kirk for James Kirk, and asks for a ransom in Monero between 500 and 1,500 US dollars. So pretty high amount. And finally, you've got like the last category is where I put like basically all the rest, all the scams, which are related to cryptocurrencies. It can be anything which is going to like, from social engineering to some other parts, like, people are going to trust you to do something and, actually, well, it's totally fake and they're not doing it. So they will tell you, oh, if you do this or that, I'm going to give you a Bitcoin to reward you. Given the current price of a Bitcoin, it's a little bit surprising, right? But some people will trust. On Android, well, we can actually see lots of those stuff also being abused in various malware. The first thing here that we see actually is that, I've got my mouse pointer here, is that malware started to pop up around cryptocurrencies in 2014. This is where we saw quite a couple of malware with reports there abusing various currencies. And then there's suddenly not so much activity until like by the end of 2017. And then again, in 2017, it pops up on our radars with plenty of new malware around us. We don't know exactly why suddenly it pops up in 2017, but probably, of course, the market rate of the Bitcoins going up and up is probably for something, one of the reasons that attackers really gained some interest for that on mobile phones. This is basically for afterwards. You'll have the slides. If you want to investigate one of these malware personally, well, you have you've got the links there and some hashes there so that you can look into those malware for yourselves. And this is precisely what we're going to do in most of the rest of this talk, is we are going to investigate some of those recent malware. So in January 2019, so like 2 months ago, I encountered quite a few Bitcoin mobile miners. So this one is posing openly as a Bitcoin miner for Android with a very nice picture, and it's always very kind to the end user. It tells you, you know, mining Bitcoins, this is pretty intensive and it's really going to heat up your CPU and your batteries. You'd better monitor it, but we'll do it for you. So this is really very kind, right? And actually it keeps its promises on for that point. If we have a look at the code and decompile it, well, we see this this method here, which is actually indeed monitoring the temperature of the CPU, grabbing it from a file on the file system here, and then displaying it to the end user. It also told us it was mining. Yes, well, this is true, but it is not mining for you, and it is not mining Bitcoins, but it is mining Monero. For that, it is using a quite well-known library, which is known as CoinHive. And this library is a JavaScript library which will only work for Monero. And there are basically quite a couple of things here which are legitimate. So what happens is that you can just, with a few lines of code, insert this mining library into your application or into your website, and then a window will pop up and ask you, are you okay for this website or this application to do some mining on your device, right? So if it asks for consent, this is, I'd say, relatively okay. This is altered mining here. The problem is that it can be abused, and if you just use this time CoinHive library here, well, it doesn't ask for any of your consents any longer. And then, of course, it starts mining in the background, and you're not aware of it. It consumes your resources, and the money doesn't go to you, but to the attacker. And there are lots of those samples that we have in our malware database. So I had a look and scanned quite a couple of those. What you can see here is that actually, so the money which is mined goes to a given account, which is identified by this your site key, which is the identifier for the attacker. So I had a look at the various site keys that I could find in different malware, and you see that sometimes those are reused across different samples, but sometimes even more than just a couple of times. This key, for instance, was used over 287 different apps. And if you think that some apps are maybe downloaded, let's say, just only 1,000 times, this means that there are 287,000 instances of of people potentially mining for this site key. So this is pretty lots of people. Again, in January, I don't know why, it was the month for Bitcoin miners, I guess. Another application I bumped into, again, saying and claiming openly it was a Bitcoin miner, but this time it's totally fake. It's not even mining anything else at all. It's just purely displaying an image like this one. You see there's a miner here. You've got a button here. When you play this press button, well, you have the image of like the miner going through the mine and getting some gold there. But nothing really happens except it tells you, it displays on the user interface. But as we saw, can we trust user interfaces? Well, here, it tells you it's mining, but it's not. It has also lots of settings to look like a real application. And for instance, this one is interesting here, the upgrade plan. So I had a look. At first, I am only mining 100 mega hashes per second, which is already enormous on a smartphone, but pretty cool. If I want to mine better than that, and gain more Bitcoins, of course, I can upgrade. And here I have like a demo premium plan. And if I rate them and leave a nice feedback, I will get this plan. So I did, except I didn't even have to rate them because it's not fake at that point. You just have to click and you get for free this new plan. And there you go. I got it. You have bought new miner plan. And now I am mining at 200 mega hashes per second on an Android emulator, of course. No problem there. The other one, I don't know if you noticed, but it's really, I find this one quite strange, is personalized advertising GDPR. I had never noticed that, GDPR had something to do with that, but well. And indeed, this is what the application does, is only displaying ads. So you install something, you're not mining, but you are viewing tons of advertisements. And you think about it, it's actually quite smart, because if you want an application to do some mining, especially on a smartphone, you'll probably have to run it quite a lot. If you want to run it quite a lot, it means that you will have it to display that it is running, and so you will be viewing the advertisement all the time, right? So it's one way to ensure that you are going to see the advertisement. In the end, you have, managed to get like a lot of Bitcoins, and you think it's time to go, to travel a little bit and get rich. So you want to get the money, right? Of course, it's fake. Don't dream. And actually what happens in the implementation, it's totally fake, is that you have a hard-coded four stages. You'll go first in the pending stage, then 5 days later approve, 5 days later in processing, 5 days later sent. So 15 days later, you will see that, well, actually it has been sent, but you haven't received any money, of course. But you will have been viewing advertisement for 15 days, so that is very good for them. In case you wonder, you cannot do any Bitcoin mining on a smartphone. If you are really serious about Bitcoin mining, you need dedicated hardware and you need to buy ASICs, and this is basically some of the recent one that you can get on the market, and they mine around something terahashes per second, between 30 and 70. On a smartphone, even on a good one, it's 70 hashes per second. So there's a difference of 10 to the power 12. Okay. So, you have no chance of mining anything on a smartphone for Bitcoins. February. So in February, a researcher named Luca Stefanko, discovered, a clipper, and then, on the Google Play, store. And this clipper, so it is manipulating the clipboard. I'll explain a little bit more. Here, what happens is that when you want, for instance, to send some money to somebody else using cryptocurrencies, you're going to ask him or her his address, the wallet address. And the wallet addresses are always, unfortunately, quite long and different to memorize. So I say, okay, give me your wallet address. And I'm never going to memorize this. So I put it, like most of the time, in the clipboard. And then I send, okay, I'm going to send you this amount of money. And I think I am sending it to just the address I have put in the clipboard, but the clipper has replaced this address with the address of the attacker. So actually, I'm not paying you. I am paying somebody else, giving him freely some money. So this is the code of the method which is implementing the clipboard management. It grabs here in this variable the content of the clipboard manager, and then it is going based on that, based on a very simple algorithm, trying to decide if this is an Ethereum wallet address or a Bitcoin wallet address. And depending on that, it will replace with the attacker's Ethereum wallet address or the attacker's Bitcoin wallet address. So I noticed this address here, 17M616. I thought, well, let's track and have a look at how much money they made on this address. As you may know, it's like partly anonymous Bitcoins, but you can trace the transactions. So you can go openly on the website, have a look at some at the transactions which are actually involving this address, and we can see. So this one is probably a bit small for you, but there were 6 different transactions for a total of 0.12 Bitcoins, which is approximately $500 US, and we can see the various transactions there. So not much. I cannot be sure at this point that it was all done with the Clipper malware, but I know at least that they didn't get more than $500 US based with this malware. Actually, this wasn't the first Clipper which was in the wild. There was a first one in August 2018. And it was actually slightly more advanced in the fact that it was not hard coding the wallet addresses of the malware author, but it was contacting a remote server to get the wallet address which was appropriate in this case. So this one, actually, we're going to do some live reverse engineering for this one. So I have loaded the sample there. And we have a look first at the Android manifest and have a look at where is the main activity. The main activity can be recognized quite easily by the tag here, main and launcher. And they are very nice in this case because they named it at the end main activity. So that's quite handy to recognize which is the main activity. So we can go and have a look at this main activity and decompile it. And so the main activity is the first activity which is going to pop up when you click on the application icon. And the first method which actually gets called is onCreate. That's the way it runs. And we see that it is first, well, creating a thread here. See a little bit afterwards what's happening. Then it starts a service in background, and this service is called the clipboard service. Then this line here is a specific trick to remove the application icon. Okay. And then it's going to toast a specific text on the screen. And here the text is actually not supported on your device and deleted. So it will look like the application has been uninstalled. It will say, oh, it's not supported. Remove the application, and you will have a feeling that the application is no longer there, but it is wrong. The application is still there, and some background services are still running. So the background service is clipboard service, and here in the thread, what it is doing, well, it is contacting the remote server and just sending like something a ping, which is the URL. Well, we can have a look. It is set in Gate, and Gate is populated here. So this is the remote web server, which is contacted in that case. It's no longer operational by the way. So we're going to have a look at the clipboard service. And it's basically the same thing. The first method which gets called is onCreate. Oops. I prefer to have a look at this that way. And what is it doing? Well, we see it is instantiating a clipboard manager. This one and this one. If we click here, we see that it is valued with this subclass of the clipboard service. So I go here. And in there, we see indeed the algorithm for the which is going to handle the clipboard manager. And it's basically the same thing. Here we are going to read what is in the clipboard. So I can rename that. clip text. There we go. And, well, it is going to try and make out and understand what type of address this is. So those are different payment services. This is WebMoney, I think, different instances. And then you have Monero here, Bitcoin, Dash, Dogecoin, Zcash, Ethereum, Litecoin. And the last one is Blackcoin here. And so it thinks, for instance, that it is a Litecoin if the address starts with an L and that the length is more than that. And this is more than 34 characters. Okay, so it is a simple algorithm, but apparently it works in quite a couple of cases. And what does it do? Well, the first thing is going to send a log report. This one is not very interesting, but this one here is. So this is the clipboard service. Did like that. It's always easier to read. So it instantiates a thread. In that thread, it is going to contact the remote server so this is the URL, the end of the URL, and it's going to tell what is the wallet address that it has in the clipboard manager. And here it will send that to the remote server. The remote server is going to answer with the attacker's wallet address. So now in this one, let's call it address, because it depends if it's the wallet address in the clipboard or the attacker's. In the end, here we have the attacker's wallet address. And once this is done, it is going actually to change it in the clipboard. And let's go here. So this is an address. It looks if this address is already in the clipboard or not. If it isn't, well, it's just going to copy paste it in the clipboard manager. And that's how it works. Right? So back to our slides. So those were backup slides in case it didn't work. Never know. We have also, I talked about wallet stealers. Well, we have that as well on Android. And for instance, an example that we came across was a fake Ethereum wallet. If you are into Ethereum, you might know MyEtherWallet, which is quite popular wallet for this currency. What some people don't know is that there is no mobile version for this wallet. So whenever you find, well, at least currently, a mobile version of MyEtherWallet, it is certainly not official and in some cases malicious. This is the case of this one. So you think you're installing a legitimate wallet, and the first thing it asks you for is your private key to be able to import your account, of course, right? So you enter your private key. But what happens actually, of course, is that it sends it to a remote database which is accessible to the attacker and just prints out in the end, oh, sorry, invalid credentials. I didn't manage to import your account. And meanwhile, of course, the attacker can just empty your account. Ransomware. Ransomware also, of course, popular on mobile phones. We've got a family which is known as Locker or Lockybot with over 100,000 samples for those. And it's still very active. It started in 2017. It's still active. We have some samples which are new versions in February of this year. And in the end, well, what those ransomware do, of course, is lock your screen and ask for a ransom. And the ransom is asked in Bitcoin. So we see it, for instance, here. So I thought, well, okay, how is it doing that? It would be interesting to understand how it is actually locking my screen. And so we have a look. This one in particular was posing as an Adobe Flash player. And the first thing when it installs is it's going to ask for the device administrator rights. So now if you are a security aware person, asking for device admin rights for a Flash player, this should raise an alarm, right? Because it's pretty high rights for something which obviously is not going to need it. But if you are just like the standard end user, you are probably a bit confused and you might enable those rights. Actually, at the beginning, nothing happens. The nasty things only start to begin to happen when you try to disable or uninstall the application. When you try to uninstall the application, well, it won't be uninstalled. It tells you first have to remove the device administrator rights. So you go and try to disable the device administrator rights, and there you go and you get an ugly pop-up, and it's not working. And then in the end, you get your screen locked on that ransom demand. The code. So actually, when you are trying to disable device administrator rights, you will get into a method which is called onDisableRequested. Right. And here we see that it is getting a layout, and the layout name is, well, not very easy, HFDHFX, something like that. And if we have a look at this very beautiful layout name, well, it just says enable to uninstall the application. Then what it is doing here is that it is calling a horrible named method, okay, with a horrible string, hard life, for reversers like me. So you have a look here at this method, and you see that it is the deobfuscation algorithm. I was quite lucky for this one because it's really not too complicated. First, you do an XOR with 88, and then on the next byte, the XOR will be on 3. V2 is 3. It's here. So it's quite easy to do that. The only point here is that throughout the sample, it is always changing those constants. So you just can't apply the same algorithm on all the strings. It won't work. You have to put the right constants all the time. So that makes it slightly more difficult. So we do that. And this ugly string turns into window, which is more understandable. And this means that we are getting the system service window, adding a view. So basically that means that we're going to display this window which shows enable to install application. So actually, here I should have had this text, but in my Android emulator, for a reason I don't know why, it wasn't showing. Okay. Yeah. Okay. Then after that, it is starting another activity. And this activity is a subclass of screen lock. We go and have a look there. And then again, we see that it is loading another layout, again with another ugly name. We'll shorten a little bit the task. This one is displaying the ransom. And again, it is calling a horrible little name for a method. We deobfuscate that, and this is again window. We are lucky, so it means it's going to display the ransom on the screen. So we have the ransom nodes on the screen. How does it manage to lock it that we can't move to something else? Well, it implements a method which is called onWindowFocus, which will get called each time we try and view something else. Another application, another window, another layout, something like that. And here, well, it is sending a broadcast of an intent with, again, some horrors. But when you deobfuscate, this only means, well, close system dialogues. So this is what it is doing. You try to shift to another window. It says, bam, close it. Try to move another one, close it. it will always close all the other windows that you try to open. So I thought, well, okay, let's have a look if they are profitable or not. So this is actually, I took this, yes, this address from this screenshot, this one, 19TU. Let's have a look and see if they are profitable or not, if they're getting rich with that. And I'm gone too far. The first one got 50 Bitcoins. This is a huge amount of money, $200,000. Okay, so I thought, wow, I hadn't thought they'd make that much, to be honest. Let's check it a little bit more. So again, I had a look at the various transactions on internet, and I went through a couple of the first transactions, and then things didn't exactly add up the way I had expected. I know that for this ransomware, the ransom is either $70 or 100. Not something in between. It's either 70 or 100. So then I went exactly through all the transactions, and 99.42, well, that's probably 100 with the, you know, the exchange rate. This is plausible. But this one, 19.96, this is no way near 70 or 100. This is wrong. And I'm doing that for all the transactions and ruling out those which are not coming from the sample, the malicious sample that I am looking into. And then, like a few hours later, well, I summed up all the amounts they had got, and it's only $600. Well, it's already pretty good, but it's not 200,000. It's only $600 there for this particular sample. Now, the 200,000 are maybe coming from some other malware. It's probably malicious or illicit traffic, but it's not coming from the Android sample that we have been investigating. So we have seen ransomware, things like that. You're probably wondering if we can also have some malicious miners. Well, the good point here is that miners have been banned from the Play Store in July 2018, so it hardens a little bit the task. But, of course, we can still have some malicious samples, either on Google Play or in other marketplaces. This is an example of one of those malicious miners. So this one is mining actually on a pool which is support XMR. So it is mining for Monero. And when you are mining on a pool, you usually, well, you give the username for, well, it's like an identifier to know who is mining. And then there's a user password, but this has actually nothing to do with a password. It's more like a kind of a label for the various workers. And here, what is interesting, we see in the code that it will put as, for this label, the manufacturer of the smartphone. So I had a look live at this malware mining and infecting some people. And we see here that, well, it has actually infected, at that time it had infected 4 different devices. We have Amazon, I didn't know they did smartphones, but probably, Huawei, Lenovo, and Samsung. And they were mining at 8 hashes per second, 8, and 50 hashes per second. So for a total hash rate of 66 hashes per second. This is very low, of course. In the end, for 1 month, that attacker gained $6. So, well, he's not getting rich with that one. And finally, I told you also that there were plenty of other scams, crypto scams. I particularly like this one, where we have some Android applications who are mining some cryptocurrencies which cannot be mined. So they tell you, for instance, this application is an Elite XRP. This is for Ripple miner, and Ripple cannot be mined. by design. So this is pretty stupid, but if you don't know, well, you can get fooled. There are some others here. I think that Tether miner also is another currency which cannot be mined, but they can still mine it. Everything is possible in an Android application, right? So, in the end, you might be wondering if it's possible to mine all together on a smartphone. Well, the answer is close to no. They haven't been designed to do any mining. And if you want to mine on your smartphone, beware of the heat. I know that some researchers tried, and they really kind of nearly popped their batteries. For Bitcoins, really forget it totally. But there are some other algorithms there which are far less intensive, like Kryptonite or Kryptonite Lite. And those have been designed to be at least possible to mine on CPUs. So the legitimate question there is, well, could we possibly mine those currencies on a smartphone? So I tried and gathered some hash rates with various smartphones. Those are old smartphones, and they have a pretty poor hash rate. Those are more recent and really decent smartphones, but still, it's really a ridiculous hash rate of 70 hashes per second. You need to be hashing kilo hashes, mega hashes, tera hashes, but not just hashes per second. So, well, there's no way you will. This is going to be profitable for you. Then I thought, well, okay, there's no way you can mine on a smartphone. Why do we see things like that on the web? Electroneum, the mobile-based cryptocurrency. Strange. And last month they even published about they were going to introduce on the market a smartphone for that. And look at the specs. It's a quad-core 1.3 gigahertz. This is nothing really exceptional for $80. So it's not a great smartphone and a bit strange, right? This other company also is claiming that you can mine with your phone and you will they promise 2 Ethereums per month. So you'd be able to gain something like between $250 and $300 per month. The price of the smartphone is quite expensive. This one is $3,000, so this one is expensive. Still, what is this about? Well, it's not, they're not scams. They are true. They are actually legitimate, but it's a little bit of a play on words. They are not mining on the smartphone. They are mining in the cloud. So this is pretty different, right? That smartphone for Wings Mobile, well, actually the mining occurs on a third-party pool. So you are not actually buying a smartphone for $3,000. Well, you are, but actually what you are really paying for is a mining plan on this pool. This is pretty different. And then it makes sense, okay? But it's not mining on the smartphone. Same for Electroneum. They were not mining on the smartphone. They are mining on inside their cloud. Pretty different. So, well, it's nice ideas, especially the one, so I like the one about Electroneum where the idea is to help developing countries. But the problem is that it is a little bit kind of confusing for the end user, and attackers are using this confusion. If a standard person can't know if it's possible to mine on a mobile phone or not, then it's so easy to spread scams on the marketplaces. So, it's not interesting for an individual to be mining on a mobile phone. How about attackers? Because for attackers and cyber criminals, it's pretty different. Because they have loads of smartphones that they can infect, right? They can easily infect 100,000, 300,000 smartphones. That's not such much a big deal for them. They're not paying electricity. That's also something which is interesting for them. If they damage the phone, well, they're not really looking to damage, isn't looking for that, but it's not really too much of their concern. And on top of that, you've got the other benefits of cryptocurrencies, the fact that it's sometimes difficult to trace, anonymous, or things like that. So I thought, yeah, that's another slide on another topic. Actually, I thought, well, we saw plenty of samples which are mining either Bitcoins or Monero. I thought, are they only targeting those two cryptocurrencies, or are there some other cryptocurrencies? Well, the answer is that they are targeting actually a very wide variety of cryptocurrencies. You even have some malware mining Bollywood coin. Does anybody know Bollywood coin? Well, I didn't know. Okay. Crowdcoin, Dinero, Guncoin, Orbitcoin, Omizigo, Cardano. I mean, there's really lots of those. So, how much money are they making? So we saw that with the miners, actually, they're not making that much money, right? It's like between $3 in some cases, which is really poor, and goes up perhaps to $200. We have here ADB miner, which was a little bit better, got $1,000, but this one is a little bit different because it was infecting indeed some smartphones, but also plenty of TV boxes and other devices, which were more powerful. So, it's not only smartphone infection, so it's a little bit different. The most profitable ones are, well, we saw the Clipper in February 2018, $500, and also the ransomware, around $600 there. Currently seems to be the most profitable there. So based on that, I think, scheme a few predictions. So we saw that mobile miners weren't that profitable. So I think that those will probably decrease in the future. And on the other way, we saw that wallet stealers and mobile ransomware, well, these had, a reasonable profit. It's not as profitable as it is on a computer, but still, $500, I guess that in many countries, or for script kiddies, it's an interesting amount. So those will probably increase. And finally, for the crypto scams, well, it's like easy money. You always had this we've had this for ages. This is probably going to continue. It's easy to develop. People always have some funky ideas for different attacks. So this is probably going to stay as it is for, again, the next few months or years. And that concludes my talk. And if you have any question, I'm ready to answer that.
Thank you, Axel. Any questions? Yes.
Thank you for your talk. Little question about, crypto miners are not meant to be run on phones, but do you know if there are some software that were specifically for phones trying to exploit all the power, including CPU, GPU, that is on the phone?
So, yes, the answer is basically on this slide. Well, in one of the malware. Hidden miner, there it is. Okay. So, here, minerd is a port of one of the mining software that you find traditionally for computers, Windows or Linux, which has been ported in that case for Android. So it works. You do indeed mine, except that you don't really have the power to get anything in the end. But the software works and runs on the platform. Does that answer your question? Okay.
But Do you know if it really uses the GPU or only runs on the CPU?
No, it uses the CPU.
Yes.
Thank you for your talk. At some point, you in some slide you mentioned that in mobile phone, high-end mobile phones, you would get around 70 hashes per second, while the profitability threshold would sit at around some number of terahashes per second, even. But isn't that essentially comparing two different hashing algorithms? Because I mean, 70 makes sense considering Kryptonite, which is like very intensive, but I cannot see any other, like Bitcoin, like SHA, like even a specialized hardware achieving terahashes per second with the same algorithm that Monero uses.
Yeah. So I believe you refer to. I'll get to the slide.
Yeah,
this one, I guess.
Exactly. So is this the same hashing algorithm, or are you comparing different ones? Because the disparity is too high.
Those are here. Those are the hashing rates for bitcoins. So for the algorithm for those.
Yeah.
The 70 hashes per second. You are even correct because it's worse than that. The 70 hashes per second that I have been noticing is only on Kryptonite Lite, which is it would have been worse if I had tried with bitcoins. Okay, so I can't tell you how much less it would have been because I find the idea so kind of stupid that I'm not even sure that somebody has built a miner for bitcoins on Android.
Yeah, I mean, it's definitely because of how the hashes that it uses. The profitability threshold would be much higher, but also the hash rate would be much higher. Not sure if you get what I mean.
Yes, but in that case, a smartphone would only get, let's say, something like 30 hashes per second. So it's still ridiculous. You still can't get any profit out of that.
Yeah, I'm not arguing that you would get profit with Bitcoin and not with Kryptonite. Mm-hmm. Definitely, it's very hard to get profit with either. Probably even less with Bitcoin, as you say. But the hash rate for Bitcoin is clearly higher. It's not less than 70. It's probably going to be much higher than 70.
I don't think so, no.
Okay.
But it's worth a try. If you get the results, I'll be interested to see what how many hashes per second you'll get. But I don't think you'll get more than that.
We have time for one more question. Yes.
The presentation was very interesting. I have two small questions. One is, are other network devices also being used for hashing and crypto mining?
So network devices, can you tell me what you have in mind?
Every home is now having an ADSL router roughly sitting there. And are they being targeted in any manner?
Yes. So I saw, I know that we have some IoT malware which are mining. I can't remember the name. But if you go on FortiGuard's blog, Fortinet's blog, and you search, like, I think like the last 4 months on threat research, you will find, one of our researchers, found one, less than 4 months ago. So yeah, it does happen. And it was, home router, I think, which was being infected and mining, for an attacker that way.
Thank you. Other one was one of your presentations where you had done a reverse engineering code on it. And you said the code actually said that it was being a particular type of a name given to it. Is it all what you write to it? My ignorance of reverse engineering.
Yes. So on the reverse engineering here. Here, you mean the layouts of the name of the layout here?
No. Further up into one of the other ones.
Screen lock?
No. Yeah. Those public classes, screen lock and so forth. Is it something which you get out of a classical debugger or reverse engineering code, or
Yeah.
this is what you write yourself?
It's I put the Android malware in an Android disassembler and decompiler, and it gives me the decompiled code of the application. So here's Greenlock, for instance, is the name that the malware authors gave to this class. So it's not my code, it's their code that I am decompiling.
Thank you.
You're welcome.
Thank you, Axel. And time is up. And now we have 20-minute break, and please give another round of applause for Axel.